Hello students, in this video we'll take a look at special products. So we're going to be multiplying polynomials and noticing some patterns. In example 1, our directions are to square each binomial and simplify. In part A, we've got x plus 5, quantity squared. Now remember that this tells us to multiply x plus 5 times itself, okay? And you might say we're going to use the FOIL method to do this. X times x is x squared. Outer product plus 5x. Inner product plus 5x. And last product plus 25. Now we notice that our inner and outer products are the same, don't we? So we see that plus 5x repeated. Combining like terms gives x squared plus 10x plus 25. And I want us to just notice some patterns here. Our end product is a perfect square trinomial. That's the result of multiplying x times itself to get x squared, 5 times itself to obtain 25. And our middle term is the product of x times 5 twice, or 2 of these 5x's to achieve 10x. Now as we look at part B, x minus 5 times x minus 5, and we're going to try to get a little bit faster and more efficient with each one of these that we do. Multiplying, our first term is x squared. Outer product and inner product are both minus 5x. Those combine to minus 10x. And our last product is plus 25. Notice how this perfect square trinomial compares to the perfect square trinomial from part A. And the only difference is that we have a minus 10x as our middle term compared to a plus 10x as a middle term for part A. And that's a result of the sign in between. If it's x plus 5 quantity squared, all terms are positive. If we have x minus 5 quantity squared, that middle term will be negative. Let's continue and look at part C. 3z plus 1 times 3z plus 1 and multiply. 3z times itself is 9z squared. Our outer product and inner product are both plus 3z, and they combine to plus 6z. Our last product is plus 1. Now in looking at part D and comparing to part C, it's the same except for a minus symbol, correct? So we know what this is going to look like, don't we? 3z times itself is 9z squared. Our inner and outer products are both minus 3z, and they combine to minus 6z. And lastly, negative 1 times negative 1 is positive 1. Now, as a result, we've got a couple of formulas for squaring a binomial. If you've got a binomial of the form x plus y quantity squared, our first term is x squared. Our middle term is twice the product of x times y. And our last term is y squared. If we change the sign in the middle to minus, notice that that's going to change the sign of our middle term to minus. So here we want to pick up the patterns, okay, for these special products. Not that we have to use a formula by any stretch, okay, but noticing that pattern just helps you get faster with these. In example 2, we're going to look at some different special products. Here we multiply in part A, t plus 10 times t minus 10. And as we multiply, we obtain t squared minus 10t plus 10t minus 100. So here we notice that when we multiply two binomials that look exactly alike except for the different signs in between, plus and minus, our inner and outer products will be opposites and will cancel out. Our end result here is t squared minus 100. We call this outcome a difference of squares because it involves two perfect squares with a minus sign in between. In part B, 8m plus 7 times 8m minus 7. 8m times itself is 64m squared. Outer product minus 56m. Inner product is plus 56m. Lastly, that's minus 49, and again, our inner and outer products are opposites, and they cancel each other out, giving 64m squared minus 49. Now that we've seen this twice, where our inner and outer products canceled, okay, let's pick up that pattern now and use it. In part C, we're multiplying two binomials that look exactly alike, except for the signs in between. So we know our result will look like the product of our first terms, 3r times 3r is 9r squared. We know that our inner and outer products will be opposites, so don't even worry about writing those down. Okay, they're going to cancel each other out. Last terms, negative 1/2 times a positive 1/2, multiplying straight across, gives minus 1/4. 9r squared minus 1/4. So here we're doing some speed multiplying, aren't we? In part D, we've got three polynomials to multiply. Let's start with the last two. So just carry this y down from the front. 3y minus 1 times 3y plus 1 is 9y squared minus 1. Inner and outer products cancel. Now distribute y to obtain 9y to the third minus y. And in each of these examples, parts of example 2, we've multiplied the product of a sum and difference of two terms. And anytime that we do that, our inner and outer products are canceling, and we've got the product of our first term times itself minus the last term times itself. We call this speed factoring, okay? Noticing patterns, picking them up, and using them. Last example here, find the product, 2m minus 1 quantity to the third. Okay, don't do anything crazy. All right, we know that we've got to take 2m minus 1 and multiply it times itself 3 times. We can start with any two of these, so I'm just going to write down that first binomial, 2m minus 1. And let's go ahead and multiply the second two. All right, 2m times 2m is 4m squared. Minus 2m twice combines to minus 4m. Lastly, plus 1. So we've made quick work of that first step. Now there's not really a great way to go about this next step other than just using your distributive property. Okay, I think that's the best choice for us at this point. So let's distribute 2m. 2m times 4m squared is 8m to the third. 2m times negative 4m is a negative 8m squared. 2m times 1 is 2m. Next, distribute the minus 1. Okay, minus 1 times 4m squared is minus 4m squared. Next, we've got a term called plus 4m. And lastly, minus 1. Now, as a last step, we'll combine any like terms, and it is common practice to write your terms in decreasing degree order. So let's write 8m to the third as our first term. It's of the highest degree. Negative 8m squared minus 4m squared combined to minus 12m squared. 2m plus 4m combined to 6m. And we've got our last term in there, minus 1. Okay, stop here. There are no other like terms to combine. So in this video, we've looked at special products where we want to notice patterns and use them so that we can multiply quickly. Good luck on those.